began our assignment immediately after it was assigned. We initially started by looking at various bridge designs across the internet and researching the different ways they handled tension and compression, along with how heavy they were combined with the dimensions such as length, width and height. Through this process, we were able to eliminate designs that would be realistically too advanced to make out of spaghetti and narrowed it down to a few designs we liked. To eliminate the ones we didn't want to do from the ones we wanted to do, we sat down and marked off the pros and cons of each different idea. This allowed for us to have idea inputs and collectively select a design. We decided on building a beam bridge. This meant it would contain a really strong base for the bridge, having the base much thicker than any other trusses or beams. That way the bridge would be stronger where there was much more stress. The building of the bridge went smooth for all beams and horizontal pieces. The tricky part of the whole process was getting the trusses to join and stand up straight. This took multiple hours of trial and error. We eventually worked out how to position our trusses so they would stick together and provide robust and sustainable attributes to the bridge. To achieve this, we cut our beams for the trusses on a 45-degree angle and sanded both ends so that the point of contact would fit perfectly and provide a large surface area for the glue to set and combine the two. As you can see in the test, one of the main beams snapped due to not enough glue being applied. The bridge collapsed under 2 kilograms of tension. We have a lot to work on. Things we took away from this test is that we need to add a centre beam point of contact for the trusses so that it did not collapse in the middle as quickly. We also concluded that we need to double check all our points of contact between beams so that they were all glued properly and would not fall apart.
For the new bridge, we found that the old bridge didn't have enough support through the middle. By following this, we added a vertical beam that connected to the truss and the main bridge. By doing this, it allowed more compression to the bottom of the bridge and more tension to the top of the bridge, ultimately allowing the bridge to become stronger and hold more weight. Challenges we faced with the new bridge was that we found it difficult to glue the horizontal beams to the vertical beams and the beams that were on a 45-degree angle. We found a way to make this work by drilling holes into the main part of the bridge that allowed the beams to sit in with the glue going around the beams. Time was also another challenge, as it was time consuming trying to get all the components to glue in the right spot to make it as strong as possible. Another challenge we faced was that when it came to testing day, we found we didn't make the bridge long enough, as it didn't sit on the platform nicely, causing our bridge not to be as strong as it potentially could have been. Overall, our bridge held 9 kilograms, which we found that considering we didn't make it long enough, it was a success for us. This assignment taught us that planning precisely is very important, and we have now learnt other design faults we should have avoided, but also aspects of our bridge that work well. It has taught us how important it is to take into account of which components are the tension and compression, as this is how our bridge could have been stronger.